Hello Algebra 1 students, and welcome to your video on variation and the normal distribution. I'm going to be recording a little, and then I'm going to have to stop and finish recording later on in the day today. So I have some Vivaldi playing in the background because it'll jump around a bit, and I don't want to have tracks that end up starting and stopping and all that kind of nonsense. So as it says down here, the statistics strand, the things we're talking about here, we've already talked a little about mean, median, mode, and box and whisker plots. Stem and leaf plots we'll just touch on. Histograms we're going to see in this video. Standard deviation and variance we'll see in this video, as well as the normal distribution and Z-scores. Mean absolute deviation we will learn how to do in class. Let's jump right in with some definitions. Okay. Data is often organized by being sorted into intervals. So those intervals are from 0 to 5, 6 to 10, and so on. The frequency of an interval is the number of data values in that interval, and we will practice with an example on a coming slide. A histogram is a graph that can display data from a frequency table. Like a box and whisker plot, a histogram is used to show dispersion. So a histogram looks a little bit like a bar graph, but it's continuous. Now a bar graph, when you draw a bar graph, it's distinct bars. So say, for example, I had a bar graph, I would have a bar, another bar, like that. That's not what a histogram is. A histogram is where you have bars that touch because we're talking about different intervals, and that's how many are in those individual intervals. So there's no space in between because it's continuous, and it shows the dispersion of that data in those intervals. The measures of central tendency are the statistical values that describe a data set. Those are the ones we've already covered a little bit of, mean, median, mode. Measures of dispersion are different. They describe how dispersed or spread out the values in a data set are. Range is the one you already know. We'll be finding standard deviation, and then later absolute mean absolute deviation, and we'll also find variance today. We'll talk about the normal distribution. A data set is normally distributed when it fits this 68, 95, 99.7 rule. You will learn what this is. And the Z-score of a data value is its distance from the mean measured in standard deviation. So I know that's a lot of vocabulary, a lot of information. Let's go ahead and get started with what all of this stuff actually means. Now, let's talk frequency table and a histogram. So we're going to make a frequency table here. We have test scores, and they're not in numerical order, so we are going to have to make little tally marks here. So we're going to go through, and I want you to do the same thing. I want you to make little tally marks in each of the intervals. So if a score is between 61 and 70, like this first one, this 70, we're going to put one tally mark in there. I'm going to pause it and do it as well, and then when you start the video again, you'll have your answer. Okay, so here I go. And here we go for our tally marks. Now, they didn't make the table quite big enough, so I did spill over a little bit there with the 81 to 90 area. But let's go ahead and put how many. There were 4 values between 61 and 70. There were also 4 between 71 and 80. There were 11 between 81 and 90, and 5 between 91 and 100. And if you add that up, you end up with a total of 24, which is the total number we had here. Okay, so we have the frequency, the frequency on the vertical axis, and we'll have the intervals on the horizontal axis. So we need 4 intervals. So I'm just going to start right here, 61 to 70, 61 to 70, and then the next section, try to make it the same distance, 71 to 80, same general distance here, 81 to 90, sorry for the mess, it's not very easy to write on, and then 91 to 100. And then we just put the column, in each column we put how many we had. So we're going to count by ones. So this first one was 4, so we have this bar here. The second one was also 4, so you're going to have the same height bar. The next one was 11, so 5, 6, 7, 8, 9, 10, 11. I think that goes here. Let me make sure that's right. Double count for me. Make sure I didn't do that wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good. And the last one was 5. And there's your frequency table. Histogram. So this is a histogram. You can see how it looks like a bar graph, but it's not. It's continuous. So you would find the values and you put it in histogram. Now you're going to love doing this in class because we're going to use the TI-84 Plus in order to make our histograms. This is the only one you're going to be making by hand unless we decide to make one more in class just to make sure we understand the concept. Okay. Okay, quick review and overview of when to use the different measures of variation, which is not something that we can often be tested on an SOL-style test, but we'll just go over this real quick. So remember, the mean is the average. The mean is best when there's no outliers. So remember, outliers are way far away from the rest of the numbers in a data set. The median is that middle value when they're in numerical order. That one is good when there is an outlier. That way the outlier that's far on the end to the right or left, that's far greater or far less than the rest of the values, won't affect that value too much, if at all. Okay, so the median is when there is an outlier. The mode is when your data is non-numeric or when you're choosing a most popular item, like if my survey was favorite ice cream flavor. So just a quick overview, just a review on when to use each one. All right, standard deviation and variance. So let's take a look at what these things are. First of all, we've got some symbols. So we've got this X bar here, that's the mean. Now in Virginia, we use that symbol for the mean sometimes, but we have another symbol that we use for the mean that I talked about in another video, and it's called mu. It's a Greek letter. Okay, no, I'm not making it up to make you look silly, I promise. Mu, it's this U-looking thing with a tail out front and the little tail in the back. Mu. N is the number of values in the data set. N, number of values in a data set. And so to find the variance and the standard deviation, we follow a couple of steps. The first thing we do is we find the mean. So once we have the mean, we can do the second step. You find the difference between each of the X values and the mean. So when we're doing this by hand, we make a table, and you'll see that on the next slide. Then you're going to square each of those differences. And the goal of this part, this goal of the squaring part, is to get rid of the negatives. Because when you square a negative, you get a positive. When you square a positive, you get a positive. And we got to get rid of those negatives because the next thing we're going to do is average those squares. What we want to do is average those differences. So we average the squares, and that's your variance. And your variance is this symbol. It's the mu with the squared. That's variance. And that's the standard deviation, which is the symbol by itself, squared. Variance is standard deviation squared. Okay, you do get a lot of these formulas, but these formulas are confusing. These formulas are really a set of steps of how to find, and I'm going to explain it, what this big E-shaped letter means, etc. We're going to explain that, but you do get these formulas, but it's good to have an idea of what you're actually supposed to do. The square root of the variance, you see the sigma by itself, that's the standard deviation. And again, this is another thing we will learn how to do on the TI-84, but before we learn how to do it on the TI-84, you have to be able to do it by hand at least once so that you have a clue. So let's actually do one problem, and then I think I'm going to have to stop and come back to this later on in the day to finish recording. Okay, so we have a very small data set. We only have 1, 2, 3, 4, 5 values, and I think I actually made the table too big, but that's okay. So let's start by putting our values into the table. That's our X values, 6.9, 8.7, 7.6, 4.8, and 9.0. And I did indeed make one too many there for the table. So the next thing I need is the mean. So I'm going to take my calculator, and you can do the same thing while you're waiting for me. And I'm going to go ahead and find the mean of these 5 values. So I'm double checking on my calculator. I have 6.9 plus 8.7 plus 7.6 plus 4.8 plus 9.0. And that comes out to a total of 37 divided by 5. The mean is 7.4. Okay, so when I add them all up and divide, I end up with a mean of 7.4. So the next thing I have to do is go ahead and find that difference between each of those values and the mean. And you'll notice some will be positive and some will be negative, because some of those values are below the mean and some are above. So 6.9 minus 7.4 is negative 0.5. 8.7 minus 7.4 is 1.3. 7.6 minus 7.4 is 0.2. 4.8 minus 7.4, yes, I'm using a calculator for this one because I didn't want to do the math out. I'm sorry. I know it seems like cheating. And then 9 minus 7.4, totally using the calculator again. Just trying to save time, really, guys. And I'm going to use my calculator again because I'm going to square them. Just remember, though, now, don't worry so much about whether or not it's negative right here, because you're going to be squaring it when you write it here anyway, and that's going to make it positive. So 0.5 squared comes out to be 0.25. 1.3 squared, 1.69. 0.2 squared, 0.4. 2.6 squared, remember, even though it's negative, it comes out positive, so I'm not worrying about the negative. And 1.6 squared, 2.56. Okay, now we want to add up. This is sigma. This is capital sigma. Oh, going back up here, how many values do we actually have in our data set? We have 5. Sorry, I forgot to put in the n there. Hold on. make it a little bit neater. Looked like it had a decimal point or something. Okay, sigma. And what that means is sum up. In other words, sum up, add up everything that comes after sigma. So what this is asking me to do right here is to add up all of the values in this last column. So 0.25 plus 1.69 plus 0.4. Oh, I made a mistake right there. Hello. 0.04. It's 0.04. Okay, fixing. 4 plus 6.76 plus 2.56, and we end up with 11.3. To now find the variance, we're going to take that 11.3 and divide by how many values we actually have in our data set, okay, which is 5. I just can't seem to write a 5 today. There we go. So we're going to divide by 5, and that, my friends, is the variance. Now, it's hard to explain what it means, but don't worry so much about that. Let's find the square root of that, and that's going to be our standard deviation. 1 point, and we're going to round it off. Square root of 2.26 equals 1.5. Okay, rounding it off, 1.5. And that is our standard deviation. Okay, the larger sigma is, and so 1.5 is the standard deviation, tells you how spread out the data is. The hard part is it's all a comparison. It's all relative. The larger sigma is, you see this right here? The larger sigma is, the more spread out your data is. The more spread out the data. The smaller sigma is, the more closely packed the data is. Okay, so standard deviation is a measure of relativity. It's relative. How squished together the data values are, how spread out they are. And these are pretty close together. So this is not a very large standard deviation. It's actually quite small. Okay, so now that we know what standard deviation is, we can talk about the normal distribution. Okay, so when you have a data set, we know that it is distributed in the range of the data set. So the lowest value at the left end and the highest value at the right end. But how it's distributed in between can be skewed one way or the other, or it can be even. So for example, if I had a data set and I had a histogram where the histogram looked like so, it's pretty even. But if I have a histogram and our data set looks like so, it's skewed. It's skewed one direction or another. The normal distribution gives you none of that. The normal distribution gives you a situation where your data is distributed kind of perfectly around the mean, and the mean is right there in the center. In a normal distribution, the mean, the median, and the mode are all the same value. So the mean is also the most common, and it's the central value in a normal distribution. In a normal distribution, 50% of the data is above the mean, and 50% of the data is below the mean. Furthermore, we can break it down specifically by standard deviation. So let's take a look here. Here's the mean in the center. Within one standard deviation, that means within one above or one below, there's 68% of the information. So in other words, if I know something that's normally distributed, for example, intelligence quotients, IQs are normally distributed, heights in a population, the height of the people in a population, also normally distributed, your blood pressure measurement, normally distributed. If I know what the mean is, I know that if I pick a value randomly from the data set, 68% of the time it's going to land in here. Go out one more standard deviation and you get 95%. See that 13.5, 13.5? Add all of this up, you get 95%. That means within 95% of the mean, within 2 standard deviations of the mean, you'll find 95% of your data. So the average IQ, for example, is 100. That means that if the standard deviation is 15, that 95% of the people have an IQ between 70 and 130. That means that the folks on the edges here, out on the outside, that they are in the minority, very small minority, in fact. Within 3 standard deviations of the mean, you have 99.7% of the data. And so a normal distribution is something we'll go into in more detail in class as well, and we'll use them in class. But let's finally talk about Z-score, and we'll be done with this video. Okay, Z-score. It's a measurement of how far apart the information is, or how far apart the information is from the mean, and you're measuring by standard deviation. So you find the difference between a data value and the mean, you divide by standard deviation, and that's the Z-score. When a z-score is less than 0, that means that the data value in question, that means the value in question is less than the mean. Less than mu. Okay? If the z-score is equal to 0, that means your data value in question is equal to the mean. And if your z-score is greater than 0, that means that your value of data that you're working with is greater than the mean. Sorry, that's messy. Let's fix it. So it's greater than the mean. Greater. Okay, let's find the z-score for each of these numbers over here in this data set. So the mean is in the center, so we know the mean. In this situation, we found it on the previous screen. We already know our mean, and that was 7.4. And so let's find the z-score for each one. So the formula is right there. It's value minus mean divided by standard deviation. Remember, our standard deviation was 1.5 from that previous slide. So I'm going to pause it and go ahead and calculate the z-scores with my calculator so that we can do this more quickly and get this video wrapped up. And here are our z-scores. To clarify, this is the formula that I used. Now be careful on a graphing calculator. You can't type 6.9 minus 7.4 divided by 1.5 if your order of operations isn't going to be done correctly. So you got to be very careful about this when you do it on a calculator. So what do these z-scores mean? Well, if the mu, the mean in the center, is our 7.4, these z-scores give you location. Negative 0.3 repeating, that means that this first value here is about a third below the mean. So it's about there-ish. Okay, so the second value, let me switch colors. The second value here, 0.86 with the 6 repeating. So that means that that one is about this high above the mean. So z-score gives you location on the number line in relation to the mean. A very low z-score, look down here at 4.8, means that's really far away from the mean. Specifically, let's look at that number. Where is that? Oh, nope, sorry, wrong one. Wrong one. This one. This one. Where is that? 1.73. So that's all the way down here. So that value is almost 2 standard deviations below the mean. This is difficult to do without talking about interpreting, so I'm actually going to leave your video at that and hope that you were able to pick up on all these definitions. It's stuff that we will be discussing in class, and you'll have a nice little multiple choice open note Edmodo quiz to complete for the vocabulary when you come to class next. All right, guys, thanks for watching. I know it was long. See you in class.